Hello and good day to everyone. In the last video, I have demonstrated to you how to use the analytical engine to perform certain programming applications. I am going to close this series by enumerating the events that happened after the invention of the analytical engine by Charles W. Babbage. But before that, let me give you some backgrounder on what happened before the modern period, which was the time when the analytical engine was invented. Before the time of Charles Babbage, uh, there were already mechanical calculators. In fact, by 1642 and 1644, uh, mechanical calculators was invented in France already by an inventor named Blaise Pascal. And by 1673, Gottfried von Leibniz invented the machine called step reckoner, which expanded on Pascal's ideas. uh, it expanded by doing multiplication on the machine. It's said that multiplication was done by repeated addition and shifting. Gottfried von Leibniz was a German who was an advocate of the binary system. In 1801, Joseph Marie Jacquard from France invented a loom that uses punched wooden cards to automatically weave fabrics. So here he invented a loom, which is a fabric weaving device to be able to store numbers instead of fabric designs. And by 1820, commercial calculators were developed and released. There were already mechanical calculators available for sale in Europe. This was invented by Thomas de Colmar in 1820. Now, during the modern period, particularly in 1822, Charles Babbage was commissioned by the British government to do a project called the differential engine. Its original purpose was to tabulate polynomial functions. However, it is said that it uses the decimal number system and was powered by a cranking handle like the arithmeter or the step reckoner. The project was not successful. And in 1837, Charles Babbage from Cambridge University, by the way, designed a new machine called the analytical engine, and he proposed it to be the first mechanical general purpose computer. This was the computer that I demonstrated to you using sample programs. And in 1842, uh, the work of Charles Babbage was rediscovered by Countess of Lovelace, Ada Augusta King. She was also a binary mathematician, and she demonstrated the usefulness of the machine by writing a special program called computation of the nth number in the Bernoulli series. She is now widely regarded to be the first computer programmer since she was the first to demonstrate how to write codes. And in 1884, uh, American inventor Herman Hollery invented the punch card tabulating machine. This is a very important invention because it replaced the traditional Jacquard loom. He had it patented in 1884 and marked the beginning of the automatic data processing. It's the first noted automatic, however mechanical, recording device. What happened next? After that, nothing happened because nothing significant happened in the history of computing for almost a century. That was because nobody appreciated the work of Charles W. Babbage. And when A.D. Augusta King died at an early age, nobody paid attention to the work anymore and no programs were succeedingly written. The next important event happened almost a century or more or less a century later during the Second World War. During the Second World War. Before the Second World War, however, in Iowa State University, Vincent Atanasoff and Clifford Berry invented a machine that had the essentials of a binary computer. It was completed in 1942 and is known to be nowadays as the first automatic electronic digital computer. It was specially designed to solve systems of linear equations, and however, it was not considered programmable. Another significant happened in 1939 when the Second World War was starting. Uh, the British had a very big problem with breaking the Enigma messages sent by the German army because uh, the German military are considered very advanced during that time. They were using U-boats and special machines that will encrypt their messages and will allow them to communicate quickly with other components of their army. One big problem was uh, the German U-boats usually attack supply ships that are crossing the British Channel and the Atlantic Ocean. So in response to that, the British government assembled a team at Bletchley Park in England and was solely dedicated to work on breaking breaking of Enigma codes. And by 1939, Alan Turing, who was part of the team, reinvented or invented the British bomb, and was used to hasten the computations needed by the code breaking process. Earlier, no, the code breaking process would require them weeks to complete. However, with the help of the bomb, they were able to complete the code breaking in just a matter of minutes. And this was considered to be a very important invention, and Alan Turing was considered to be a hero in the Second World War. In 1943, no, the the Germans changed their Enigma machines. They used a new Enigma machine by order of Hitler, and the British once again were not able to decode the messages of the newer Enigma machines. And by 1943, on the same Bletchley Park team, the Colossus Mark I was invented. It was said to be a set of computers used to aid in the code breaking of a newer Enigma machines. Now, it was considered already to be a full computer, but no documentation was recovered from the Colossus Mark I, such that the invention of the first digital computer was not credited to the British. The credit of having invented the first digital computer went to the Americans. In 1944, Harvard Mark I was invented by Howard Aiken from IBM. This is a popular computer because uh, this is where the jargon bug was coined. And the series of computers uh, assembled, or rather used after the Harvard Mark I, were later known as the Harvard class of computers. These were computers that were patterned after the analytical engine, where the source code runs on the IBM punch card, or in the case of the analytical engine, must be the Jacquard loom. Programs or the source code are run on the input and output device called the punch card, while the memory was used uh, solely for storing variables. Excuse me. Officially, the first electronic computer was introduced in 1945 in University of Pennsylvania. It was developed at the Moore School of Engineering by J. Presper Eckert and John Moakley. It was uh, it was believed then that one of the original team members to work on the succeeding project called EDVAC was John von Neumann, who was also a professor in another school called Princeton College. Princeton College was important because it is where the first uh, store program concept computer was invented in its Institute of Advanced Sciences. It was developed by John von Neumann in 1945. Also about the same time, the EDVAC project was initiated by J. Presper Eckert and John Moakley in order to create a ballistic research laboratory, or rather to aid the ballistic research laboratory of the US Army research in 1952. Unlike its predecessor, the EDVAC was a binary computer and was designed to be a stored program computer. However, the credit of inventing the stored program concept was accredited to John von Neumann. In 1951, the group of Eckert and Moakley also developed a third version of their machine called the UNIVAC, which was used to aid the Census Bureau of the United States. And in 1954, the first third programming language was invented and released in 1957 by John Backus of IBM. IBM became a very important sector in the invention of the first computers because they were the first to develop the IBM 701, which was the officially adopted IAS stored program concept of IBM and Harvard. In the next series, I'm going to show you the architecture of the IAS computer and introduce you to the instruction set and illustrate example programs. Thank you and see you then.